Okay, so we're going to solve trig equations. We're going to try to do it with a little bit more complicated one. So it's just like solving that we did in class together. So if you've missed the solving, it's still the same kind of idea. This is just a little one step beyond. So what do I mean with a complicated argument? So we're going to solve, meaning we're going to find what kind of angle, what is that theta right there, whatever they call the variable, what angle will give you when you take the cosine of 2 times, that's 2 times that angle, will give you 1/2. Okay, so that's what we're solving for, the theta in this case, or whatever they call it. Okay, could be another variable, it could be an x, it could be a u, something. Okay, so okay, we're going to solve trig equations. So what do I mean by solving? That means we are trying to find this variable theta. We're trying to find the angle that will make this equation true. So if you took the cosine of 2 times whatever that angle is that you find, it will equal 1/2. Usually what they do is they tell you, like, we want to find every angle between 0 and 2 pi, for example, in this one, meaning one time around the circle, or they'll tell you find every single theta in the whole existence, right? Going forwards in perpetuity or backwards in perpetuity. In this case, they just want one time around the circle. So, what do I mean by a complicated argument? That means like they don't just have a normal theta in there, they have 2 theta or 3 theta or 2 theta plus 1. So, we're talking about something that's a little bit more complex here. So, what are we going to do? We're going to make our lives easier, and we're just going to say we're going to substitute an x in there. So, we're going to make this problem into the cosine of x equals 1/2. Okay, so that simplified our life a whole lot by doing that. So now what do? We just solve like we normally do. So we would be trying to find every value, every angle where the cosine is equal to 1/2. So again, this is not restricted because it's not the inverse. So let's draw a unit circle on there. Sorry, not sure why I used red for that. Okay, so again, this is the cosine ratio, adjacent over hypotenuse, or x over r. So, and it's also, that ratio is positive. Okay, so where is the cosine positive? The cosine is positive in quadrant 1. Everything is positive there. And it's also positive in quadrant 4. You have to know this. You have to know all these little details, okay? Okay, so cosines are like x's. So x's are positive in quadrants 1 and 4. So if we do adjacent over hypotenuse for that triangle and adjacent over hypotenuse for that triangle, I hope that you're recognizing that this is a 30, 60, 90, a special right. And which one in particular is it? This is with the root 3 opposite there. That's a 60-degree angle. Okay, in quadrants 1 and quadrant 4, where the cosine is positive. I'm not sure why it did that weird thing there. Cosine has got positive ratios. Okay. All right, so if you're going one time around the circle, right, you're starting here and you're going around the circle, and then here at 60 is the same as pi over 3. At pi over 3, your cosine of 60 degrees will equal positive 1/2. Keep going around. Keep going around. There's negative cosine there. There's negative cosine there. And then you get all the way to here. And then you have another angle. So if that's pi over 3. Remember, this is 3 pi over 3. Geez, this thing wants to change everything into circles. Stop that. Okay, 4 pi over 3. This is, right, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. This is 5 pi over 3 right here. Okay, so there's the next one. So at pi over 3, it's the cosine of pi over 3 is equal to positive 1/2. And then going all the way around, the cosine of 5 pi over 3 is also equal to 1/2. And here we go. There, we went one time around the circle, right? We started here, we ended there. Okay, went this way. Started and stopped. Okay, so what do we have for our answer here? We say that x is equal to pi over 3 plus every forward or backwards rotation, or x is equal to 5 pi over 3 plus or minus, right, every forward or backwards rotation around the circle, right? So back at the circle here, if you were, okay, just go with it. I know it said 0 to 2 pi, but you have to do this rule first to check, all right? Because I'm going to show you in a second why. So first of all, you want to write these kind of rules for every, man, this thing is not wanting to work tonight. Sorry. For all possible, I'm too close to that thing there. For all possible angles, okay? So just write the rules first and I'll show you why. So basically, this is like what I showed you in the first day when we did this. You hit pi over 3, and then every rotation, every time you hit that pi over 3, your cosine of x is going to equal to 1/2, right? And same goes for 5 pi over 3. Every time you hit that, go sweeping around the circle, your cosine of x is going to equal 1/2. So that's what this rule is saying. Every time you're at pi over 3 plus every forward rotation or backwards rotation, that's what the 2 pi is, okay? So, all right, so now we wrote our rules. The reason we did that is because we didn't really just solve for x. Remember, we came in the beginning and we switched out 2 theta. We switched for x right here. So we weren't really solving for x, we were really solving for 2 theta. So now, after you've written this rule, this is when you come back in, and it wasn't really x, it was 2 theta equals pi over 3 plus or minus 2 pi k. And same here, it was 2 theta equals 5 pi over 3 plus or minus 2 pi k. All right, so we're actually looking for theta. We're still looking for theta. Well, guess what? The reason we did that, we're going to do a little bit of algebra. It is 2 times theta here. So to get theta by itself, you're going to divide everything by 2. Little bit of algebra. So this is one step beyond, okay? So you're going to get, so your 2's cancel out there. Theta is equal to pi over 6. All right, I can tell some of you are going to want to know how that happened. Just give me a second. Okay, here the 2's cancel out here, plus pi k. And then here, theta is equal to 5 pi over 6 plus or minus pi k. Wow. Okay. So that changes life a little bit. The reason we're writing all of these so-called these rules, as I call it, is you'll see why. We have to check all of these, and we're going to do that thing with the, we're going to check all the iterations of this to see which values are within one rotation here. It sounds worse than it is, so let's just go with it. So first of all, let's see how we did that little fraction there. Pi over 3 divided by 2, the same as 2 over 1. Remember, let's get rid of that downstairs there, the denominator. So multiply by the reciprocal top and bottom. And there you go. Pi times 1 is pi, and 3 times 2 is 6. Okay? So I'll just get rid of that here for a second. Okay, so now we want all of our answers, the thetas, in between as 0 and 2 pi. Okay? So we're going to have to do this little thing where we say, okay, so we're going to start. Remember, k is an integer, 0, 1, 2, 3, etc. Okay, so we're actually going to play that game. We're going to say, we're going to test each case for k equals 0. Let's start with that. Then you have theta is equal to pi over 6. And since it's positive rotations, we can get rid of that minus sign thing there too. Okay, since it's not going backwards, it just wanted to know one forward rotation. Okay, so pi over 6 plus pi times 0. Well, anything times 0 is just 0. So pi over 6 plus 0 equals pi over 6. Okay, and there's our first answer. Is pi over 6 with in between 0 and 2 pi? Yes, we are happy with that. Okay, let's try another one for k equals 1. Theta is equal to pi over 6. Just using this rule. This is the rule here. Okay, this right here. That's the rule. Pi over 6 plus pi times now 1. So this is the k right here. This is k right here, okay? So what is that equal to? Pi over 6 fraction, people. Pi is the same as 6 pi over 6, right? So 1 pi over 6 plus 6 pi over 6 gives you 7 pi over 6. Is 7 pi over 6 in between 0 and 2 pi? Oh, what is 2 pi and 6 anyway? 12 pi over 6, okay? So 7 pi over 6 is in between 0 and 12 pi over 6. All right, so this is just tedious, but you keep going. So let's do for k equals 2. So theta equals, what's the rule? Pi over 6 plus pi times now 2, right? This is the rule right here. This is your rule. That's what I'm using. So what is that? Pi over 6 plus 6 pi over 6 times 2 over 1, right? 2 is the same as 2 over 1. Well, what is that? 12 pi plus 1 pi over 6. 12 pi over 6 plus 1 pi over 6 is 13 pi over 6. Is that in between 0 and 2 pi, or 0 and 12 pi over 6? No, this does not work. Okay, this is good. And this is good right here, okay? Well, guess what? We're going to do exactly the same thing with this second rule over here. Because remember, so what we just did was this one right here. Okay? Now we got to do this second one over here. Okay? All right, so that's what this rule is right here. So I'm going to write this over here so it's a little bit cleaner. Here's the rule that we made. Theta is equal to 5 pi over 6 plus pi k. So for k equals 0, theta would equal 5 pi over 6 plus pi times, what is k now? 0. Anything times 0 cancels out. So you're going to end up with 5 pi over 6. Is 5 pi over 6 in between 0 and 2 pi? I know y'all don't like thinking about pies, but pi is the same thing, remember, as 12 pi over 6. So is 5 pi over 6 in between 0 and 12 pi over 6? Yes, we're good there. Okay, so let's try the next k. Remember, k is just an integer talking about which rotation you're trying. That was no times around. Now we're going to try one whole time around. K equals 1. So theta equals 5 pi over 6 plus pi times 1. That's 5 pi over 6 plus 6 pi over 6 is the same as, wow, this thing is full of life tonight. 6 pi over 6 is the same as pi times 1. So 5 pi over 6 plus 6 pi over 6 equals 11 pi over 6. Okay. Is that in between a 0 and 12 pi? Fortunately, a yes, right? Okay, so this one is also good. All right, so you could probably see with the next one, we just keep stepping it up with those counters. 5 pi over 6 plus pi times k equals 2 now. So 2 pi plus 5 pi over 6, we're already over our border, right? We're already over the 0 to 2 pi with this, so this is not going to work, okay? Just like on the last one. So what are our answers there? What are the answers? You say your angle is equal to, so we had one here, pi over 6 that we circled, 7 pi over 6 that we circled, and over here 5 pi over 6 and 11 pi over 6. And those are your answers, okay? So again, I'll just kind of recap this. If you need to stop and pause anywhere along the way. Okay, moving over here. This was our original problem. Okay, so whenever you have a complicated something or other in here besides just a nice simple one variable here, you're going to replace that with something like x. Okay, and then you solve your equation for x. The cosine of the cosine of x equals 1/2. Positive ratios of cosine are in quadrants 1 and 4. And we figured out that that was a 60-degree angle in those two quadrants that would give you, or pi over 3 is 60 degrees, right? In those two quadrants that would solve that. So we wrote the rule that every time you're sweeping around the unit circle and you hit pi over 3, so pi over 3 plus every time you sweep around the circle, you're going to hit a cosine of 1/2. And same for this rule over here. Every time you're sweeping around the circle and you hit 5 pi over 3, and anytime you hit that on a rotation, you're going to get a cosine equal to 1/2. Okay, so this is where it comes in at the end. We weren't really solving for x. We really had a 2 theta over there in your problem right here. Okay, so instead of writing x, we substitute back in the 2 theta in the very end in the rules here. And to get theta by itself, we do a little algebra, just divide by 2 everywhere. And we end up with our real rule here. Theta, if you divide that out by 2, is pi over 6 plus pi k. Okay? So the reason you have to do that rule is because it's not obvious, after you've divided this and done some algebra, like, ooh, am I in between 0 and 2 pi? I don't know. And who thinks in pies anyway? Okay, so just use the rule and then try k equals 0, then 1, then 2. That means no rotation, 1 rotation, 2 rotation, 3 rotation. Okay? So just stick in k equals 0 into the rule, k equals 1 into the rule, and then keep going until you get out of bounds there, okay? So if you got 6's going on, I would change that 2 pi into 6, which would be 12 pi over 6. And then you can know where you're at. Okay, so that's a recap. Hope this helps. I'll try to be back. I've got lots of example problems. If you understand the basic idea behind it, you need to practice this. As you can tell, this whole thing was for that little tiny problem there. So thank you. Hope this helps.